Hi, Adam.
Hi, Bob.
How you doing?
Good.
Good. Let me introduce us. I'm Robert Wright. This is the Wright Show. You are Adam Frank, a professor of astrophysics at the University of Rochester. Also, author of a couple of books, The Constant Fire, Beyond the Science versus Religion Debate, and About Time, Cosmology and Culture at the Twilight of the Big Bang. You are also co-founder of the blog that can be found at npr.org. And the blog is called 13.7, Cosmos and Culture. And you write for that periodically. I noticed you posted something, I think today, in fact.
Yep. About once a week I write. There's 5 of us who are part of the blog.
Okay. Well, impressive as all those accomplishments are, none of them is the primary reason that we are here. We're here because you recently wrote a paper about the chances that that we are not alone in this universe. In other words, that there is, or at least has been at some time in the past, a species somewhat like us in the sense that they're kind of smart enough to generate technology. And so, presumably a species we could in principle have a conversation with since they would presumably, one of us would presumably be advanced enough to overcome any translation problems, right?
Right.
Now, the argument you're making is that thanks to developments in astrophysics over in recent years, we can now actually carry this question to a higher level of precision. We can say a little more now about what the chances are that there has been or is a species somewhat like us somewhere in the universe than was the case even, I guess, 10 or 20 years ago, right?
Right.
And what is it? What is the development that allows us to put a finer point on this question now?
Well, essentially, it's what we might call the exoplanet revolution, right? So the question about whether or not there were any planets orbiting other stars is ancient, right? You can find the Greeks talking about it. You can find the philosophers, Persian astronomers talking about it. Romans, it goes all the way back. It's actually called the many worlds question. And so, or the plurality of worlds. So this question about whether or not other stars host planets, people have gone back and forth about. And there was actually a long period for about 100 years or almost 100 years, where people were pretty convinced that planets were very rare, right? So, basically nobody knew. And then in 1996, we began this remarkable period where we started discovering, getting very clear evidence for the existence of planets around other stars. And it took a little while for that to really ramp up, but now basically we know. We know, that there are planets around other stars, and in fact we know that pretty much every star you see in the sky has, a couple of planets, or about at least one planet going around it. And then more than that, we've also been able to nail down, pretty well, the number of planets in the habitable zone. Planets are in the right distance from the star so that it's neither too hot or too cold for liquid water to be on the surface, which is our definition of habitability.
Okay.
So,
and to be clear, when we estimate the number of habitable planets, then we don't mean that we know there's water on the planet. We just mean that it's in the temperature zone that would, in theory, permit water and the evolution of life as we know it.
Right. I mean, obviously there's a big, there's a whole set of assumptions that water equals the possibility for life. But, based on what we understand about life on Earth and what we understand, water is a pretty amazing molecule, right? Its solubility, its ability to act as a carrier for other kinds of chemical reactions make it pretty unique. And it's hard to find other things that could play as a facile role, if that's the right word, for biochemistry. So, given that definition, that liquid water on the surface is the first thing you need for life, then that's how we define habitability. Now, of course, what we found from our own solar system is we've got the moons of the giant planets, which have subsurface oceans, right? So nobody had even thought about that beforehand. So, in some sense, you got to add that in. But for right now, for what we were doing in this astrobiology paper, really, we were just using the definition of habitability. So to answer your question, it has been this remarkable revolution in our understanding of planets in the universe that has allowed us to sort of take one step further in addressing this question about other intelligent species.
So over what period, last 10 years, last 20 years, has the kind of revolution happened? I mean, it seems like I've seen a lot of news stories about this over the last 10 or 20 years. But what is the technology that has given us a clearer idea of the number of habitable planets in the universe, and what is the time span over which it is?
Well, like I said, it was 1996 was the first discovery. 1995 or 1996 was the first discovery of an exoplanet.
Okay, and an exoplanet just means a planet not in our solar system, right?
Exactly.
Okay.
Right. So this has been, astronomers. This has been a holy grail for astronomers for as long as there was astronomy, essentially, or at least stellar astronomy. But the precision. It was basically the instruments. The precision of the instruments just wasn't there. So the first way we discovered planets orbiting other stars was via what's called the reflex method. Basically, you can't see the planet. The planet is just completely is swamped. The reflected light from the planet is swamped by the light from the star. But what you can do is, the planet and the star are orbiting each other. And, even though the planet is a lot less massive than the star, it still has a tug on the star. So as they're orbiting each other, the planet is actually the star is shifting back and forth a teeny tiny amount. And what you needed were instruments that were powerful enough to be able to detect that slight drift forward and drift back of the star in order to be able to tell, oh, there's a planet there. So that was 1995, 1996, that class of instrument was well tested enough that we could begin using it to find planets. And then later on, the second method that became very powerful was what's called the transit method. And that's when when a planet passes in front of a star, you see this tiny diminution in the starlight. Mm-hmm. And that's actually even a better method for finding planets, because what happens is, by looking at how long it takes for the light to dim and how deep the diminution is, you can actually tell things like the size of the planet. So those two methods together, along with some others, have really taken us from not knowing that there were any planets to now pretty much having, I think there's on the order of 3,000 confirmed, I think that's around the right number, 3,000 confirmed exoplanets. But that's also now the statistics are good enough to now infer pretty much that every star in the sky has a planet.
Okay. And we're able to see things clearly enough to say whether they're in the habitable zone temperature-wise based on these kinds of measurements.
Yep. Because the habitable zone is a relatively easy calculation to do, because all you have to know is how hot the star is. You have to know how much light the star is putting out. And from that, you can calculate, if I drop a rock here, how hot is that rock going to get? If I drop a rock there, how hard it's going to get? So it's a relatively easy thing to do a first order calculation of habitability. Now, of course, go ahead.
Well, just out of curiosity, how do you know how far the planet is from the sun based on the measurements you've described?
Well, like the period, you can tell by how long.
Okay, so just the periodicity of it.
Yeah.
Okay, so you said there are 3,000 known exoplanets. I assume they are in our neighborhood, generally speaking. I assume we can see things closer to us better than we can see things far away. Are they all in our galaxy?
Yeah, we've only looked in our galaxy so far. So, the Kepler satellite, which was the most potent astro or exoplanet hunter, has been looking at just one patch of sky. I think now actually since it had an accident, and so now I think it's in a different mode. But the first few years of it was just looking at one patch of sky, and it wasn't looking necessarily super nearby. I don't know what the limits of its distance were, but actually one of the things that we're really interested in is that what we're really interested in are planets orbiting what are called red dwarf stars, or M dwarfs. These are stars that are smaller than the sun, which happen to be most stars are actually smaller than the sun. The sun is not average, actually. The sun's a little bit more massive than the average star, and those stars tend to be pretty faint. But because there's so many of them, those should be the ones that are closest to us. So actually, Kepler did not necessarily see lots of those because they're so faint. So we're going to have to do other kinds of searches that are looking for those ones, to really focus on the ones that are faint and nearby.
Okay. And so of the 3,000 known exoplanets, about how many are in the habitable zone?
What it turns out, I wouldn't put it that way. What I'd say is that what we know is, I put as a general statistics, what we know is about 20% of those are in the habitable zone. Mm-hmm. So a pretty reasonable number, right? I mean, it could have been 1 in 10 trillion, right? Mm-hmm. In which case you're in trouble. But it turns out to be, a reasonable fraction seem to be in the habitable zone.
Okay, and then I guess the methodology is to, look in our neighborhood, so to speak, at the kind of frequency or density of exoplanets, the percentage of those that are in the habitable zone, and then assume that the rest of the universe is like our neighborhood, right? And extrapolating. Do people ever call that assumption into question on grounds that, hey, we're in this neighborhood, so maybe this neighborhood is more conducive to life than the average neighborhood? It's kind of an anthropic principle type objection.
With astronomy, what we've really found is that, pretty much the whole universe looks pretty similar in terms of the physical processes that are going on, right? So, I can look at stars in this galaxy, and I can look at stars in a galaxy 100 million light years away, and they still have the same spectral lines. They still have the same elements. They still have all the physics that we can tell operate, that we understand how it operates, we see operating in distant objects as well as nearby objects. And so there's really no reason, based on all these years of doing, astronomy and galactic science and extragalactic science and cosmology, to think that the rules change in any appreciable way as we go out. Now, that doesn't mean, people have thought about the idea of galactic habitable zones. It may be that the center of the galaxy, for example, may be a place that's a little bit more difficult to get life starting because you've got, say, so many supernova going off, or that the edges of the galaxy are going to be a hard place for life going because maybe you don't have as many metals. You don't have what we call metals. What we mean is heavy elements that will form planets and then form life. So, there may be gradations, maybe gradients of likelihood for life to form.
And where are we in our galaxy? An embarrassing question to ask. You'd think any person on this planet should know where they stand in the scheme of things. But are we closer to the middle of our galaxy or to the...
We're about midway out. The galaxy's a big disk, and we're about midway out through it, a little bit less than midway. So, and we actually seem to be in the, what people would call is right in the middle of the galactic habitable zone, where there's not too many supernova going off, and there's enough, heavy elements that have formed from other stars and enriched, the solar system that we were born into, so that life could form.
Okay, so let me try to quickly summarize your argument as I understand it, and then you can either stop me when I go awry and get something wrong, or just wait and add nuance at the end.
Yes, that's my job.
But basically the idea is, and this gets back to the famous Drake equation.
Right.
Now, the Drake equation, so that's the kind of known, Carl Sagan type equation that everyone's heard of, where we try to figure out what the chances are that there's somebody out there, so to speak, other than us, very much associated with the SETI, S-E-T, the search for extraterrestrial intelligence thing. There's one difference between the Drake equation and what you're up to. The Drake equation was devoted to finding out if there is now a species like us, for reasons we can get into, but don't have to right away, I think. You chose to look at the question of whether there is now or has ever been a technological species,
Well, we had to ask that. I mean, that's an important distinction, because in order to use the data, right, what we wanted to do was we wanted to use this incredible revolution that we're in the middle of, where we've got all this great data, to be able to say something. And in order to say something with that data, we had to change the question. So it's actually very important that the change that we made, it wasn't like an arbitrary decision. It was like, this is the only way we're going to be able to answer. We had to change the question to find the question we could answer.
Okay, so here's how you approach it, I think. You say, in answering this question, there's basically two key factors, or maybe clusters of factors, to consider. On the one hand, there's like, how many habitable planets are there? And then there's the question of, for any given habitable planet, what are the chances that you're going to wind up with a technological species? And that in turn can be broken down into, what are the chances life will arise?
Right.
What are the chances, you can break it up however you want, but there are assumptions in there about like how likely natural selection is to create an intelligent species, intelligent enough to generate technology, and so on.
Right.
But anyway, your point is that if you go back to this first factor, how many exoplanets are there? How many habitable planets are there likely to be in the universe? Your point is, we know a whole lot more about that question than we used to. So, though there are still some big unknowns on the other side, in that second factor about the likelihood of the origin of life.
Yeah, those are completely unknown. All of those are entirely unknown. It's anybody's guess those other factors.
Right, but the interesting thing you do is you say, well, but by filling in that first factor, we can at least precisely say how unlikely the advent of a technological species on a typical exoplanet would have to be, or typical habitable planet would have to be, for us to be alone in the universe, right?
Right.
So that's kind of an interesting way to think about it. But before we go there, let's get back to that first factor. So, like, how many? I mean, I think well, let me go to the kind of the punchline. You say, and I think we can infer from this roughly how many habitable planets there are. But you say, as long as the probability that a habitable zone planet develops a technological species is larger than 10 to the minus 24th, then the chances are that there has been at least one other species like us. And I think, if I remember correctly, 10 to the minus 24th is 1 over 1 with 24 zeros. Is that right?
Yeah. So that's a trillion.
Okay. So
it's 1 in a trillion.
So you're saying, so if the probability of a technological species developing on a given habitable planet is higher than 1 in a trillion, then we have not been alone. I mean, there is something like us out there now, or there has been. That's your rough calculation.
Yep. Which to me is mind-blowing, right? I mean, so So what we get is we can talk about how we actually got there. But what we calculate from the data, is that we call it the pessimism line, right? Because the question is always, the problem with the Drake equation is that it always sort of ended up being an argument between pessimists and optimists for the various terms. What is the probability that a given planet that's in the habitable zone actually has an abiogenesis event, that life forms? Well, the pessimist will say, well, it's probably pretty likely. Here's my argument, so it's close to 1. The optimist says it's close to 1. The pessimist says, no. Here's my argument. It's 1 in a billion. And what we've shown is that unless you are like a hyper pessimist, unless you're insanely pessimistic, then it is overwhelmingly likely that the sequence of events that goes from life all the way up to a full-blown civilization, have happened before. It doesn't mean that there's around now, but that there is overwhelming. You just have to be. Nobody's that pessimistic. And if you look at the history of SETI, nobody would be so pessimistic to say that the odds were 1 in a trillion. So let's take the guy who was, sort of 1 in a trillion. He was so pessimistic that he thought the odds were 1 in a trillion. Well, from our calculation, what we're showing is, it's happened then 1 trillion times. Yeah. There's been 1 trillion histories on planets of species going from, slime up to some kind of intelligence, all the way up to some kind of technologically deploying civilization like we are. 1 trillion. I mean, that's you could spend every 5 minutes you came up with a new kind of, Star Trek alien. You still probably you'd run out of time in your life to come up with 1 trillion versions of that.
So you would say to this guy who says, I think the chances are only 1 in a trillion, you would say to him, but you're not a pessimist.
Right.
You think you're a pessimist, but now that we know how many habitable planets there are, that's optimism. That means there probably has been something like us out there.
Well, the important point to make, though, is that if the question is, can we communicate with them now? I would say I have no idea, right? It could be that because then there's one, you talked about the 2 different kinds of factors. There's the astronomy factors in the Drake equation, and then there's the biology, sociology, technological factors, right? But there's actually a third factor, which is the average lifetime of a species, right? How long does a civilization like ours last? And we have no idea about that. And if that lifetime is short, and by short it could, even 1 million years a lifetime could be short, then none of these civilizations last long enough for there to be anybody around now to communicate with locally. So,
and I want to get into this at some length, these kinds of questions that are raised by this. But first, let me check. Can I infer from the number we just threw out that the number of habitable planets is somewhere around 1 trillion? In other words,
yes,
these have to be in the same ballpark, right?
Yeah, that's basically, I mean, what we did, it's actually, so the number of habitable planets in the observable universe, give or take, 10 or 100, is 10 billion trillion, right? 10 billion trillion.
10
so
billion trillion or 1 trillion.
Yeah, 10 billion. So basically what we did is we just said, okay, 1 over that number is approximately the probability we're interested in, but we also added another factor of 100 to sort of say, like, statistically, you'd want to run the universe a couple of 100 times, because, basically you don't trust anything statistically unless you have 100 samples or 1,000 samples. So that was why, that was just sort of those extra 2 digits. But, basically anywhere around, the number is approximately a trillion.
I'm not sure I get that last revision, but maybe I don't have to. Why you added that?
That's an important point. It's really just essentially what we were saying was that in order to ensure, there was the way that the argument was built, in order to ensure that this probability we were coming up with was low enough that it set the limit, whereby if the actual probability is lower than this, then we are truly alone. That's how we set up the argument. If the probability that nature chooses, right, with all of its processes of evolution, is below this limit that we set, then we are truly alone. And so we had to, we just, by statistical arguments, we had to set it at 1 in a trillion rather than 1 in 10 billion trillion.
Okay.
But it's a small point. It's not.
Okay.
There's so many zeros there. A couple of zeros.
Yeah, once I get past a billion trillion or so, I turn it over to the experts like you to tell me how many additional zeros I should throw in. So there's a lot of interesting stuff here. I mean, one is this set of factors that you say is more or less imponderable. What are the chances that you would get a technological species? My own view, I mean, I've actually made extended arguments that are relevant to this. I in a book called Nonzero, I made an argument both that technological evolution has a direction and that biological evolution by natural selection also, in a probabilistic sense, favors the eventual development of a species smart enough to launch technological evolution. And in fact, I argued that the dynamics of the two processes are really pretty similar, and at some level of abstraction, I'm making the same argument about the two processes. But at any rate, I argued that part, I would assign a reasonably high probability to that part. But then it seems to me what's even, and there are arguments about this, as you know. One thing I'm curious about is, do astrophysicists get into those arguments in trying to assign even a ballpark number to that second factor, or is it just do you just treat that as a complete imponderable?
People, but this is what's really interesting is you see people trying to understand when it comes to the evolution of technological civilizations. You see people trying to understand or trying to break the problem apart, where they can try and set probabilities for steps, right? This idea, there was an interesting paper by Carter in '83 and then Watson in not too long ago, where they were trying to say, like, look, we can at least try to identify the critical steps in getting from non-life all the way up to civilization, and then try to assign probability distributions for them based on something like when it appeared. Like, it seemed like in the history of the Earth, it was pretty easy for simple organisms to be created, but then there's this huge gap between multicellular organisms. So, but actually giving a number for any of those, you can do like distributions, but actually giving a number, it's pretty hard. There's just not a whole lot. There's not a whole lot of data to sort of hold on to.
I mean, another kind of factor you would consider is that although it took a while for multicellular life to get very robustly off the ground, it was independently invented, apparently, on a number of occasions. It didn't just happen once, and that's the kind of thing that's relevant. I would think
that's right. Those are the kind of like the Bayesian arguments that people try to use. You have a little bit of information. What can you extract from that?
I would think the biggest imponderable is the actual advent of life itself. It just seems to me we don't have a clue about that, really.
Well, why? I think I'm much more optimistic. I'm not an expert in this field, right? And there's a lot to that field, but the pathway, because I teach an astrobiology course, when I run through the arguments for that about the probabilities of, how many amino acid chains do you need in order, and how many times do they have to collide, I think we have a reasonable path to that argument. It doesn't seem to me to be to me, actually, that is a lot easier step than intelligence, or self-consciousness.
Really?
Yeah, because
I don't think so. But
So the argument from the biology part of this is like, there's one level, this is just chemical evolution. You got a pool and you've got a bunch of reactions that occur, and whichever reaction happens the fastest wins, right? And so if you can just get a self-replicator, something that's even a quasi-self-replicator happening, then basically in that pond, the self-replicator wins, And so, when you look at the arguments based on chemical kinetics, how fast does this reaction occur versus that reaction occur, you can come up with, at least from what I've seen, pretty reasonable arguments to A, get a replicator, just by stuff bouncing into each other, and then B, for that replicator to begin, doing more interesting things.
Well, it's certainly true that once you have self-replication of physical pattern that's really robust and stable, you have a pretty good model for world domination. I mean, it's like because nothing else is lasting. You're the thing that is lasting. Yeah. On the other hand, the idea of truly stable, endlessly intergenerational transmission of information is itself kind of mind-blowing to me. I mean, that's like not an easy. High fidelity copying is not an easy thing.
No, that's an interesting point. And I was talking with a guy not too long ago, and he was talking about how the whole idea, how in the studies of the origin of life, how the emphasis shifted from, in the 50s, it was that Miller-Urey experiment where they were able to make amino acids in a tube, which was all about chemistry. And then it was, in the 60s and 70s that it really became about information processing. Right? That was the real key question. How do you start encoding, dense amounts of information, in these molecules, it's not DNA yet, right? So how do you get to that point such that, as you say, you're copying effectively and robustly? So that I agree that those are interesting questions, but it just doesn't seem to me, I can see natural processes making that happen without too much trouble.
Well, also there's something almost a little anthropocentric about us just kind of assuming it wouldn't have happened in a lot of places. It's like, why are we so special,
Right. Well, the interesting thing about this thing, I think there's all intuitively, right? And, for always, you can go back. I'm just reading the history of this. So I'm writing a third book now, which is about this argument. And, for me, it ties a lot to what's happening with us with sustainability and climate change. Mm-hmm. If you look at the history of the what's called the plurality of worlds argument, Fontenelle, who was a writer in the 17th century, he looks at the sky and says, look, there's so many stars. Of course, there's got to be other creatures like us. So I think we all intuitively have had that feeling that it's true. But the problem is once you get down to it, right, and you start looking in detail, the question is whether or not the improbabilities, right, begin to pile up on you. So, there's the book Rare Earth that, which is around what Brownlee and Ward wrote, where they were like, yeah, sure, simple life, no problem. That probably happens easily. But if you look at the history of the Earth, why was there such a long gap between getting the first life and then complex life? So their argument was like complex life requires an infinite number of miracles, not miracles, but an infinite number of improbable events so that, it's probably pretty damn rare.
I think it just requires time. It's an inherently arduous process. It's like random variation adding up to stuff takes time, but you do have this selective process that we do. Anyway, so I would argue that once you've got self-replication that's truly stable, you're not home free, but things are looking good if you've got enough time.
Right.
Now, so you're saying that in some sense, your reading of all this is in a way more optimistic than traditional readings have been, in the sense that you're saying, even if you're fairly pessimistic about the chances of life coming to such a planet, a habitable planet, and turning into a technological species, there's still a good chance that there's something out there or has been. Let me take this optimistic argument and try to put a pessimistic spin on it. And maybe you've heard this, I don't know. So, one question that starts emerging as we discover more and more habitable planets in our neighborhood, right, is like, well, why haven't we been contacted, right? Because if you assume, let's say there's 100 of them within a couple thousand light years, okay? Well, some of them are going to be a few hundred years ahead of us technologically, probably a few thousand. And you got to assume that given the current rate of technological change here, if you were a few hundred years ahead of us even, you would be able to communicate with somebody a couple thousand light years away as fast as the laws of physics permit, which would presumably mean you would send a message and it would take 2,000 years to get there.
Right.
But that's like doable, right? So So I guess then so you have to assume that like if they're 2,000 light years away, that they're maybe 2,500 years ahead of us technologically, so that like, 2,000 years ago, they were smart enough to send us this message that would be getting here right now. You take the point, right? It's like the more of these things you find in your neighborhood, the more of these things that are conjectured to be in your neighborhood, the more puzzling it is that you haven't been contacted by any of them. And one possible answer is that, you've probably heard, I don't know, that when you get to roughly the level we are at, you blow the whole thing up in one way or another. And there's reason to think that's not implausible when you look around at the world today, whether you want to go environmental catastrophe or you want to look at weapons of mass destruction combined with all the virulent tribalism in the world or whatever. So at some point, your optimistic reading starts making me pessimistic about our own chances of making it very much further. Does that make any sense?
It does, and that's the Fermi paradox, right? You're aware of that argument goes under the Fermi paradox, where Fermi, supposedly the story goes in 1950, he and a bunch of buddies are, Fermi was this Nobel Prize winning physicist, and they're going to lunch at Los Alamos. And, there's been a UFO sighting, and they're talking about UFO sightings. They're talking about, the alien intelligence. And then they move on to other thing, and they're in the middle of lunch, and suddenly Fermi looks up and goes, well, why aren't they here already? Right? Mm-hmm. So he was the one who sort of, got that idea. They're like, wait a minute, even if they were traveling at light speed, or at a tenth of a light speed, given enough time, not even that long, it takes about 100, you can calculate, it takes, 100,000 light or 100,000 years or so to make it across. So yeah, why aren't they on the steps of the White House steps right now?
Right.
So that argument, I think there's a bunch of, well, first of all, there's a bunch of arguments to counter that. But let me just step way back and say about what we did, right? Our argument is completely about whether or not they've ever existed, right? The question we had to formally ask was, have they ever existed in the history of the universe? We say nothing about whether or not they exist now. There's nothing we can say about it.
Although the higher one probability gets, the higher the other one gets.
Right. But it's amazing, actually, because of the size of things, how, because again, and it all depends on that, the lifetime, right? Mm-hmm. Because even if it's incredibly probable for it to happen, and the lifetime of a species is 200 years, you could still have, that could mean that right now the universe is essentially empty. There's, depending on the lifetime you choose, you could still get a universe where there's like, everybody's widely separated, and it's pretty, it would actually be pretty rare for there to be any right now. So that's a really important distinction that all depends on that, what I call the final factor, right? Nice dramatic name, which is the lifetime. So your point about blowing it up, I think is absolutely essential. And really what I think is, it's far more, the real blowing things up is climate change. What I'm arguing is the whole reason I'm doing this research, I love aliens as much as the next guy, but what I'm really interested in, what came to me, and actually was from my work with NPR. They asked me to do some stuff about the physics of cities. I started thinking about the idea that the transition that we're going through, the Anthropocene. Are you familiar with that term?
I've heard the word, but why don't you elaborate?
Yeah, why don't we go? So the Anthropocene is, here's the idea, right? Humanity has now entered an era where we are the principal drivers for the coupled planetary systems. Coupled planetary systems are, this is a term that came out of, actually originated when people were thinking about the Gaia hypothesis, but it's the idea that you've got the ocean, the atmosphere, the hydrosphere, which is all the water, the cryosphere, which is all the ice, the geosphere, which is, the land, etc., and the biosphere. They're all strongly coupled systems, and that basically human beings are now the primary drivers of changes in those coupled systems, right? Which is amazing, right? That's an amazing thing that we've reached to, and that's really what climate change is about. So that, there's different, scientists have different names for different epochs, right? So there's the Holocene and the Pleistocene, right? So the idea is we've just entered the Anthropocene, which is basically where, 1,000 years from now, a geologist could look back at the layers in the soil and see like, oh, something interesting happened here.
Right?
So what my argument is that the Anthropocene is it's not something that like Democrats and Republicans should be yelling about, or business interests versus environmental interests. This is really a question of a predictable planetary transition, that any species that reaches a point where it's using as much energy as we use has got to, by the second law of thermodynamics, start pushing, some of that energy, the waste from that energy flows back into the system, and it's going to change the system. So, pretty much, and this is why I'm working on research on this right now to show this is true, that pretty much any species that harvests a lot of energy via civilization is going to drive an Anthropocene-like event. And if they don't manage it well, then yeah, that cuts off their evolution.
But they could manage it well. I mean, it's not like a law of physics that all the degraded energy has to collapse on us or something.
It's the cosmic teenagerhood, right? Basically, when you're a teenager, you get a car, they give you the keys to the car, and you can buy beer, and either you get through it, and you mature and you understand how to deal with the responsibility, or you don't. And that's really what we are right now. This is childhood end for us. This is our final exam, and either we make it or we don't. And I think this is happening. Yeah. This has probably happened many, many times.
But there's good news about that being the problem. If you compare it to what I think is the biggest problem, which is like tribalism run amok in a context of like not just nuclear weapons, but more and more creepy, potentially biological weapons.
Yeah.
The good news is this. Climate change is at least, it's kind of a negative feedback problem in the sense that once we get around to doing something about it, now granted, that's a political challenge, and we haven't done a very good job of that, but I think we have a pretty clear idea. The things that policy advocates are pushing for would probably make things better.
Oh, yeah.
Okay,
yeah.
So whereas in the war on terrorism, our typical policy response is to do things that make it worse, in my view, ranging from invading countries to many other things. And that seems to be not atypical with this type of thing, with human conflict. But it seems to be particularly true of this kind of new type of challenge from non-state actors. So it's easier for me to imagine a positive feedback downward spiral in the case of this so-called war on terror than it is in the case, what I imagine with climate change is it gets worse and worse, and eventually we start doing smart things. Now, granted, there's such a long delay.
That's the problem.
That is a problem.
It really could. By that time, it's too late, right? By that time, you're committed to 5 degrees of warming, and it's just a different kind of planet where the project of civilization would be But I take your point, and it's a good point. And see what the interesting thing about this is. So when I deal with this problem, what I'm always trying to avoid is any kind of like science fiction stories, right? So who the hell knows what these other civilizations are like in terms of their sociology, their economic? I mean, you don't even want to go there because we just have, there's nothing we can say about it. Are they hive minds? Are they? So what is interesting to me is that when it comes to like climate change, when it comes to driving the ecosystem or the coupled planetary systems into a new regime, it doesn't matter whether they have little antennas on their head. It doesn't matter what they're like. This is like this comes down to a problem about chemistry and physics and timescales for choices. Mm-hmm. So that's what I think is A, makes it universal, and B, makes it tractable to say something about. Because, right, I mean, and here's the interesting thing too about like, when it comes to the war on terrorism or nuclear war, as a species, we don't have a whole lot of say in that, right? Somebody's going to push the button or not. The best people can do is vote for an intelligent person. Good luck. But, when it comes to the response to climate change, that is actually planetary, right? And that's where really this becomes, what's happening to us becomes an exemplar of something universal. Maybe we're the only warlike species in the entire universe. Maybe we're the only ones who are that dumb, right? But no matter what, any species that starts using energy to build civilization is going to have the same problem we have.
Yeah, that's true. Well, I would argue that any species that evolved by natural selection is also going to face the problem of tribalism. But
I mean, that's possible. But the problem there is, that is possible. But the number of assumptions you have to bring into that are so much larger than the number of assumptions that
actually, I think you'd be surprised.
Well, because there's so much about there's so many arguments you're making about the pathways of evolution that are specific to to this planet that I think.
Right, but you got to remember that the whole argument for the likelihood of the evolution of intelligent life depends on getting clear on which evolved properties are subject to contingency and which are more generic. so to look at, I mean, you can also do this with technological evolution, where you just look around and you say, well, look, if farming was invented 5 times independently, it was probably going to happen. It was not preordained which civilization would be the first to generate farming, and so on with intelligence. It's like, you know, if grasping appendages have been invented a number of times, which they have independently,
right,
then of course it's a matter of contingency which species was going to be the first, not to mention which was going to be the first to pair that with a high intelligence, which was a really critical fusion. But the point is that some things, natural selection is a process of discovering properties and exploiting them. It's
right.
an inventive process. And if you look at things that have been invented repeatedly, there's reason to believe that those are kind of generic things that would have been stumbled on, whereas the particular details of the species that might have stumbled on them first.
But tribalism, I mean, the particular thing about tribalism, you know, is like, I just don't think there's been enough example, like, you know, or even if we take like bonobos, right? The classic example that bonobos get together and they, you know, they all have sex to make decisions rather than beat the crap out of each other. Yeah. You know, you can certainly imagine that.
I think there's a certain amount of bonobo romanticism floating around, to be perfectly honest with you, but I haven't looked into it. In any event, I would point out that among primates, if the more idyllic stories about bonobos are true, they are the exception. I mean, and actually, there's reason to think they are something of an exception. There are certain parameters like sexual dimorphism that suggest there's been like less conflict among males. But if you look at chimpanzees, gorillas, baboons, they do horrific things to each other, and that, sadly, there's a clear reason why natural selection would tend to produce species like that. So anyway, we needn't get off on that.
Yeah, I certainly understand the argument. Just there's a little more contingency there than, and you know, it's funny because astronomers do play these games, you know, and they try to, like, you know, about the idea of convergent evolution. You know, intelligence is going to happen. You know, just like we've seen legs happen many times, intelligence is going to happen. But then what's been interesting is when the evolutionary biologists come in, they like smack the astronomers over the heads and say, what are you talking about? You know, so I've seen this happen a number of times where astronomers will try and build these arguments, you know, with these other fields and then really get taken down by the people in those fields. So, you know, I just don't, you know, it's possible, and I understand the arguments, but what I'm hoping for are things that I can have a little bit more purchase on in making generalizations.
Well, what I would say, and you might not agree with this either, but I do think there's been some concern lately about, like, if extraterrestrials show up. I think it was maybe Stephen Hawking or Elon Musk or both said, wait a second, are you sure we want to contact these guys? They may be mean and they're smarter than us. But my view is, if they got past, I mean, either you're right and they're not tribalistic to begin with, and so maybe they're not so threatening, or I'm right and they are tribalistic. But I would say if they've gotten past our stage of kind of planetary integration, you might say, kind of needing to start getting along with one another to keep the planet on an even keel to even last another 500 years, I would say if they've gotten past that successfully, they are in some sense morally enlightened in a way that we are not. They would just not be inclined to kill whatever they run into the way human explorers have in the past.
Yeah, I think there's something to that, because I actually think that the you know, when I talk about this, the Anthropocene for other species, that the Anthropocene is an example of something that's predictable, and that it's a kind of planetary transition. Because really, you know, what are we fundamentally? We're an expression of the planet as much as leaves and grass are an expression of the planet, right? So that you know, and what we're doing is we're an agent for the planet to transform itself, right? And if, in order to make this transition to sustainability, it's clear that we have to evolve new behaviors. The tribalism that you talk about will just not stand under the pressures, the evolutionary pressures that, you know, climate change and sustainability drive. So I think there is a point that in order to make it to the next level, and we have a paper right now that we've just submitted. I'm working with actually an urban theorist, and someone who studies the Earth systems, where we're positing that, look, you know, if this transition gets made, if this is a universal transition, then there's a whole class of planets out there that are sustainable, right? That where the technological species that actually developed some kind of cooperative relationship with the biosphere and fundamentally changed the biosphere so that there's some kind of long-term balance that has been achieved, and that has got to change. That's an evolutionary change for the planet as a whole and the species itself. So I kind of agree. If you're going to make it to maturity, then you've gotten some hold on yourself, and you've gotten some hold on your ability to have cooperative behaviors, which is what's absolutely necessary, has become much more evolved.
Right. And I guess what I'm saying with tribalism is having cooperative behaviors is more than being smart. It's more than sensing a non-zero sum opportunity and calmly harnessing the potential for synergy and cooperation, because in our species at least, there are so many occasions where there are non-zero sum solutions. There's all these people now who are fighting who could both be better off if they stopped. But they don't stop because human perception is warped by natural selection such that we're all inclined to think we're more in the right than we are and that the other guys are more in the wrong than they are. And so that's why I say it's not just, you're right that cooperation is what there has to be. I'm just saying one impediment to that is a kind of moral blindness that if indeed tribalism is a pretty generic thing, then any species like us would have to overcome this moral blindness, I'm suggesting.
Right. No, that's interesting. So it's interesting, like either way, you sort of end up with this need to evolve new behaviors, right? You're going to need to evolve past, natural selection gave you a certain set of skills and tools, and they were awesome for getting you to where you were, but then, basically that in order to maintain, because this is the thing, when people talk about the Anthropocene and climate change and they're like, oh my God, we have to save the planet. The planet's going to be fine, right? The planet's just going to move on without us and go on to the next thing that it wants to be, or next, the next change in the biosphere. But in order for us to be part of that, we obviously have to adapt, to the responses of the biosphere to our inputs. Yeah, and that may very well require really some fundamental changes, as you say, in the moral calculus that the species is able to undertake.
And personally, I want to be part of it. Just speaking only for myself, I don't want the future to happen without either me or beings remarkably like me around to see what's going on. I guess you could argue that we'll do more damage than good, but
no, I think actually, again, I really take, so there's this idea of the noosphere.
Pierre Teilhard de Chardin's idea. He was this Catholic, this Jesuit, both a paleontologist and a theologian / philosopher.
Very interesting guy, right? Yeah. And so, he developed this idea of the noosphere where he said, look, because the idea of the biosphere had just been created a little bit earlier by some Russian theorists. So, he was like, oh yeah, okay, so evolution, you go from just a planet, which is a geosphere, and then eventually life kind of, takes a hold and you have the biosphere. And his idea was that eventually there would become this sort of, noosphere, a sphere of intelligence. For him, it had a lot of Catholicism in it, a lot of idea of the world soul.
Right.
But I think what is interesting to happen is that, people noticed in the 1990s, like, wait a minute, the internet,
Right.
He just built
He was writing this stuff like in the 30s.
Right.
And he was already pointing to things just like TV and radio and saying, look, there's a nervous system for a global superorganism being built. He actually put it that way. He used the term superorganism. And so this is the brain or the global mind, and the noosphere assumes stewardship of the biosphere. I don't know if he said that, but that's the idea, is that we are building the brain that will govern the planet.
And here's the interesting thing about that, right? So, there was also, there's this other idea in the 70s called the Gaia hypothesis, right? So the Gaia hypothesis, got a lot of, people laughed at it, but actually it was a very important piece of thinking in earth sciences. So the Gaia hypothesis was basically that the planet is a superorganism, the biosphere is a superorganism.
We should say in a slightly different sense. It was like they weren't talking about the internet becoming a global brain. They were saying, for some time now, they were saying, the whole ecosystem had exhibited some kind of self-regulating tendencies.
It's a thermostat. It acts as its own thermostat, keeping the planet happy for life.
Right.
Now, I think people, justifiably like that's a little too teleological.
Mm-hmm.
But what came out of that were two things. One was the whole idea of Earth system science. People recognized like, whoa, there are all these parts, and the biosphere is a hugely important part. And one of the things we've recognized in this paper that we just put out is we're saying like, you know what? Once you get intelligence, once you get a global species that figures out how to, come into some kind of cooperative arrangement with the biosphere, then that's Gaia. So it's like, once you develop a noosphere, through technology and, and you sort of arrange yourself that you have information sharing among the intelligent species, then you actually complete the Gaia hypothesis, because now it does become self-selecting. For example, in order to have a long-term presence on the planet, we're done with ice ages. Right? We'll never let another ice age happen. We've already, the ice age should have already occurred by most people's estimate. We've held it back with climate change. So like, in some sense, when you hijack the biosphere, when an intelligent species hijacks the biosphere and then learns how to manage that transition, you're inherently developing a noosphere and you inherently complete Gaia. You get a planet that is self-regulating.
Okay. And I mean, the teleological question remains, well, you can separate it, I guess, and it remains open. I don't think it's crazy to imagine that, in some sense or another, I mean, we don't know how life started on this planet. There's the Francis Crick hypothesis where some other civilization seeded the planet with life, in which case you could say there might be in some sense. So whatever, but it certainly, if you view the planet in time lapse, if you could, see these several billion years pass in time lapse, I think more than people appreciate, it would look kind of like a single unified thing evolving. I mean, especially once you throw in the global brain thing. And to me, that's kind of the icing on the cake.
Well, I think that's what, what's interesting, I think, is once you get a global, intelligent, energy-intensive species, then you have involved a global brain. Before that, the question before that is, what is the biosphere? And I think it's reasonable to think of the biosphere as a whole, as an entity, as a living, it's not necessarily one living organism or superorganism, but there's certainly a sense in which it is alive, right? It is, it is a active, interdependent system. So it's not entirely, crazy to think of it that way. But certainly once you get intelligence and the intelligence is able to reaches this point, makes that evolutionary transition, then you do have a global brain. You do. I mean, without doubt, you have one.
And there is this strong incentive, just the fact of non-zero-sum dynamics between human beings, which makes it in our interest to communicate with one another and do business and do deals and solve problems and pursue common interests and so on. So it's a pretty stubborn kind of logic. So have you gotten, I assume you've gotten a fair amount of attention for this paper. Where did it appear? The journal it appeared in is what,
Astrobiology, which is, sort of the premier journal of astrobiological studies, which has exploded over the last 20, 30 years. We got, obviously, anything with aliens, people love it. People love aliens. Who doesn't love aliens,
I agree.
I love aliens,
totally,
but of course, I got contacted by people who wanted to talk about pyramids on Mars, and it was like, no, thank you.
Right.
But we did, we got a lot of attention because I'm very excited about this result. It's remarkably simple to derive. Like there's no mathematical magic in making it. But it blew my mind when we stumbled across it. And it started because we were interested in this idea of the astrobiology of the Anthropocene. We started working on this idea of how common is what is happening to us. And that's how we ended up we needed this number. We needed to know whether or not we could argue that statistically there'd been enough other species, whether they are around or not, that, what we're going through is, that there's averages we can appeal to. People really have responded to it, and which I'm excited about. And I think there's more to be done. I think there's actually more in thinking about what we're going through as a generic kind of problem. I think there's more to be done.
Like the adolescence of the planet. Planets have adolescences.
Right.
Maybe.
Yeah, I think planets have adolescences. And imagine this. Imagine we do make it, right? Imagine we make it and we figure out how to, how to become sustainable, have a long-term presence, all the evolutionary changes in us, morally, behaviorally, think of what we'd be capable of, man. I mean, it's just like, who knows? Imagine a million years of human evolution. What would we become? So, I think there's really, it's anybody's guess. If we can just make it through this, it's the bottleneck. If we can just make it through this, I think, there's some remarkable transitions that we could be part of that have already happened, that other species have probably made it through. Maybe not many, but
If you just imagine, like, if right now, today, all of the kind of more mindless conflict in the world, in other words, conflict where both sides are kind of thinking they're in the right and the truth is somewhere in between and they're fighting like cats and dogs. If you just set aside all that, imagine how much more productively our human resources could be used even in the short term, let alone what would be possible 10, 20, 100 years from now.
So for me, of course, I'm biased. I'm an astronomer. But I actually think this perspective on what, I don't think humanity really understands what it is, right? In 1968, there was that famous Apollo picture of the Earth floating in space. That was the beginning of something. But of course, in my second book, I was really looking at how ideas, in science, how they actually change society. And it's until you have some kind of technological effect, until you have some kind of technology based on the idea, it's just an idea. Climate change is that technology, right? Climate change is forcing us to make a transition which we might not have made any other way. And so, in some sense, this is the moment when we actually understand, we're the aliens, We are just one of trillions, perhaps, of species that have evolved on planets, and we either make it, we either get thrown into the pile of, cosmic winners, or we're cosmic losers, And I think, if we started teaching our kids that from the beginning, this idea of big history, which you may have heard, that, instead of teaching people about history that started when, the Romans, whatever, did their stuff in Germany, really we should be teaching history that starts with the Big Bang, so we truly understand what we are. I think that's almost the only way we're going to make it to the next, through this bottleneck.
Yeah, well, climate change is a big non-zero sum problem. In other words, it would be in our interest, our common interest, to cooperate to solve the problem. But it's far from the only one. There's a ton of non-zero sum problems arguing for international cooperation. And so if logic prevails, we will be in good shape.
We can only hope.
We can only hope. Now, finally, just to get a sense for some other things you're interested in, some other things you're up to, and maybe some of these will be related to this. I think today's blog post by you on 13.7 Cosmos and Culture, the memorably named 13.7 Cosmos and Culture blog at npr.org, I think you got into Buddhism a little, right? And you've done that in the past. So what is you have a particular, because Buddha, you can imagine, one prescription for saving the world is get everybody to meditate until they chill a little bit. But
that would be good.
Yeah, that would be good. What is your own interest in Buddhism?
Well, I have multiple interests in it. First of all, I started sitting, 30 years ago. I've been staring at a wall for 30 years.
So you do Zen then, I take it.
I do, yeah. Well, I've tried different kinds, but Zen is pretty much the where I landed. And I started for all the usual reasons people start. I wanted to chill out. People told me about it. It seemed pretty cool, But then, I have a strong interest in philosophy, right? I had a minor in philosophy. I have a strong interest in the nature of consciousness. I'm particularly interested in how you situate physics in experience. For me, experience is irreducible. That's why, in college, I did a lot of work with the phenomenologists, Husserl and Heidegger. I've always had a strong interest in that. And so, to me, experience comes first, and then theorizing about the world comes second. And what I realized with, Buddhism or any of the contemplative practices, this was actually a way of doing first-person investigation of awareness, which pretty much science, you can hook my brain up all day to a functional MRI. You're still not going to get my experience of eating an apple.
Exactly.
Right? So Buddhism, what I like about it is it's got this mechanism developed over 2,500 years for attempting a stabilized investigation of awareness. And so it's got both, I think, deep, interesting issues that it raises about how to talk about consciousness. And then also, it's got this other side, which is dude, chill out, understand. Yeah, contemplative practice allows you to see. What I like about a contemplative practice, it shows you you're an asshole way before you even have the asshole thought, and that is very useful. Right? You're like, there it is.
If you can head the assholiness off at the pass, you can save yourself a lot of time and anguish.
Right. That is what is so useful about it. So, there's the personal part, which I think would be very useful. I don't care what form of meditation people use, But then I think there's, this I'm very interested in the issue, the debates of mind, the nature of mind. And I think there's a huge problem with, now, and again, I'm not an expert on this, so people can come beat up on me about it. But I think there's a huge problem with thinking that you can address the nature of subjectivity by ignoring subjectivity, right? By only doing third-person accounts. So in that way, I think there's a lot to be learned from thinking about contemplative practice and what goes on in it. And then B, actually, what my specific piece today was about, when we think about philosophy, we tend to think about, dudes from Europe, right? But both, classical Indian and classical Buddhist philosophy, Asia, these were really smart people who were thinking about similar problems. Right. They came at it in a different way. And whether, the whole idea that, physics shows Buddhism is true, that's bullshit, Pardon my language. I'm not sure if I can do that on the show.
You can go further than that. Not that I encourage it, but you could have gone further than that.
But that was a bunch of silliness. Thank God we're done with that. But, the philosophical insights, the metaphors that have come from, Buddhist ideas about the nature of the relative and the absolute, those may be just as rich and interesting as looking at Cartesian metaphors, or Platonic metaphors, to draw from science. So I think we really need to open our eyes up to the, all the other civilizations and how they thought about these problems to maybe find some answers to things that, things in physics that we're having trouble with, like the nature of time, how to understand what's going on in quantum mechanics. It's worthwhile to at least bring those different perspectives in and see if they stimulate interesting metaphors for our thinking.
Well, and at a maybe more pedestrian level, just psychology, too, is clearly can draw some illumination. I mean, the reasons Western scientists want to be careful about relying on first-hand reports of subjective experiences because, of course, science is supposed to deal with the publicly observable. Right. You can't know what it's like to be me. I can't know what it's like to be you. So I take that caution. On the other hand, there's clearly a kind of intellectual value that comes from, so-called phenomenology, just kind of describing your interior life, your subjective experience. And I think you're right that long, long ago, Buddhism had turned that into a pretty rigorous exercise. Right. And I think one part of psychology proper there's potential synergy with is this whole recently popular study of cognitive biases, of how unreliable the human mind is, and we're drawn to believe things that aren't true, and blah, blah, blah. I really think Buddhist philosophy has a fair amount to say about that. Plus, it has this technique that can help you overcome problems like this. So
Right. And I think the interesting thing about this, too, is that the issue that you raise, I think, is a real one, right? I mean, how do we have intersubjective discussions, right? And so that's something that are scientifically reasonable, scientifically useful. But the thing is that discussion hasn't even really gotten started. There's been so much rejection, of it, that the idea of like, okay, well, how do we develop techniques? Let's go through and test those techniques, see how they can work. There was the book that Varela and Evan Thompson, I forgot who else wrote, the Embodied Mind. And that book was written, it was a great book, and it was written like 20 years ago. And I was talking with Evan Thompson about it, and I was like, did anybody pick up on this? And he's like, not really, So it's like, and it wasn't like people criticized that that it was crap. They just, people have been unwilling to sort of like, now let's pick this up. Like with any science, like, okay, let's see what we can do with this.
Yeah, I had Evan Thompson on recently, and I failed to interrogate him about the embodied mind. I think I should have. We were talking about his more recent book on different states of consciousness, but I want somebody to explain to me what exactly embodied mind means, because I always have trouble grokking it. Maybe you have.
Well, I can make an attempt at it, right? So I'm not an expert in it, but one of our other writers, Alva Noe, who's the philosopher, cognitive scientist, he often he takes that perspective too. It's the idea that again, this is the idea that experience is irreducible, right? Your experience comes from the body, right? For me, what I always say is that there's nobody has ever experienced the world except through a perspective, right? I'm looking out from my two eyes, and when people have this idea of objectivity, you say, what's the objective worldview? They just sort of imagine a disembodied perspective floating over a planet or something. So it's the idea that like there is no experience of the world that isn't embodied, right? Mm-hmm. Our everything we can think about the world, everything that we can conceive about the world begins with this experience, which is itself through a body. And to try and like ignore that, right? So, science was very successful because of its emphasis on objectivity. And I'm all for objectivity, but the reality is objectivity is a myth. It's a useful myth, but if you carry it too far, you can get yourself into trouble. Nobody's ever experienced the objective world, right? And to ignore that fact, I think hampers progress in dealing with some very interesting questions where we'd like to.
Although in theory, Buddhist enlightenment, if you believe it exists, could get you a lot closer to an objective perspective than we typically have, right?
Well, especially, so my thing today was on Dogen, right? The Eihei Dogen, the 13th century. And I think he might take exception with that. I mean, but again, I'm not an expert on this, but I don't think Buddhism would say there's, again, because what Buddhism is really interested in is this relationship between the relative and the absolute. And so that distinction between objective and non-objective, that's what they do away with. You can't make the distinction between an objective world, the absolute and the relative. They are the same. Form is emptiness. Emptiness is form, right? So the whole process is to try and unhinge that the mind wants dichotomies. The mind thinks in dichotomies. And what I think people like Dogen are saying is those are illusions. They're convenient myths, and through practice, right? Practice is the direct experience of the world before distinctions are made, right? And that's why you got the koans, the crazy questions. What is the sound of one hand? Mm-hmm. All these non-logical questions that you're supposed to probe to get you beyond directly, right? Mm-hmm. Beyond the distinctions.
Yeah. Yeah, I'll have to ponder that. I mean, I guess I had been thinking, and we shouldn't go on too much longer about this since it's not what we came to talk about. But if you look at what gives us a subjective experience in the conventional sense of a very kind of self-centered perspective, like the view of the world that's from inside my head, but moreover, the apprehension of the world that is produced by this brain that was designed to serve my own interests and not yours, and so on. If you look at the subjectivity that is created by that, so much of it has to do with either being attracted to things and clinging to them, or being averse to things and avoiding them. Not just in the obvious sense of my hand grasping things, but at an intellectual level, right? There are ideas that bother me and I shy away from them. There's things I want to believe, I cling to them. It seems to me if you get rid of all, and as you know, fundamental to Buddhism is getting over both the clinging and the aversion.
Right.
Well, if you really did that, it just seems to me that the whole glue that holds together the selfish version of the subjective perspective kind of dissolves. And I don't know what you're left with, but I think it's less subjective than what I've got now.
Yeah, well, yeah, right. I think, because it's funny because, in contemplative practice, that's kind of what you're aiming for. And of course, it's always nominal, right? I think, at least, what little experience I've had of it is in the sense that it's temporary, right? Thoughts come, they start to dominate, and then you're able to let them go, and then they come and they let them go. But the whole point of, right, one of the essences of Buddhism is there's no self, there's no fixed self,
right?
And so once that goes, that constant yes, no, yes, no, yes, no, then there's a more sort of primordial experience of the world, and to what degree that's objective, I think maybe there I'm pushing back a little bit, but it's again I think it's beyond that category of objective or not objective, because I think that's what they're asking for.
Mm-hmm. Mm-hmm. Okay, well that's a sufficiently deep thought to close on, I guess. You won the competition for deep
as opposed to Go Mets,
Well, there's that.
Yeah.
And there's the NBA playoffs, but we will not go there.
Yeah,
But anyway, thank you. Sounds like there's plenty for us to talk about. Should we have another conversation?
Yeah, that'd be great. It was a real pleasure. I really enjoyed it. It was a really interesting conversation.
So did I. And let's do it again sometime.
Okay, great.
All right. Thanks a lot.
Take care.